This week on Waterways, Photo Mosaic documentation of the Florida Keys Shipwreck Trail, and harmful algal blooms, also known as the red tide. The Florida Keys National Marine Sanctuary is an amazing place. Corals, fish, lobsters, dolphins, shipwrecks. And now the Florida Keys National Marine Sanctuary is bringing the underwater treasures to you. No longer do you need to be a diver or a snorkeler to enjoy the wonders of the sanctuary. Through the NOAA-funded Photo Mosaic Project, underwater archaeologists are now delivering images of Keys shipwrecks, detailed high-resolution photo-mosaics, to anyone who is interested in learning more about South Florida's rich maritime heritage.
So what we're doing is basically flying over the shipwreck with a scooter sled. There's two big scooters with a sled in between. I've mounted sonars to and a camera. We fly over the shipwreck site with a video camera pointing straight down, and what I do is taking software on a computer, I pull out the still frames from the video, piece those frames together like a giant jigsaw puzzle, creating a photo mosaic of the entire shipwreck below. So now you can see the whole shipwreck at one time. Using a photo mosaic to document a site isn't a new process. The big guys like Bob Ballard on the Titanic have been doing it for years, but they use very expensive pieces of equipment to do it. Submersibles, ROVs, what have you. Those are really expensive, hundreds of thousands of dollars a day to do these sort of operations with the whole team you got to put together. What we're doing is the same thing but on a much smaller scale. I can do it for 1/100th of the price.
Casserly figured that he could build a variation of Ballard's machine at 1/100th of the price by using one diver, a scooter sled, a video camera, and sonar.
With the sonar, the video camera and the housing, which are always expensive, and the scooter itself, it's probably about $20,000. But the product it produces is priceless.
Casserly and NOAA teams began years ago with a diver propulsion vehicle, a DPV, that would pull a second diver who would hold a video camera straight down, pointed at the wreck. But this technique had problems. Keeping a constant distance from the shipwreck was difficult. The distance needs to be uniform so that the images taken back to the lab would have the same proportions. A difference of a few feet while filming underwater would make an object too big, or too small to fit neatly into the puzzle. So they came up with a new way, with sonar attached to the sled.
So now I've got these handheld sonar devices mounted to a sled. So I've knocked out a whole other diver completely. It's just one-man operation. So you've got a stable sled platform straddled by two diver propulsion vehicles with sonar, which will tell you exactly how far you are off the deck of a shipwreck. So if you say, I need to be 30 feet off the shipwreck, you can glide across and stay at that constant height the whole time with the sonar. And then I've got a video camera mounted right up to the bow of the sled, pointed straight down, and I just fly it myself, holding a level course.
In 2001, they tested their new invention on the USS Monitor and at Thunder Bay National Marine Sanctuary with great success. Then they came to the Florida Keys and created a photo mosaic of the deep wreck, the Queen of Nassau. Lying in more than 200 feet of water, several miles off Isla Morada, beyond the reach of most recreational divers, this pristine wreck of an early 20th century steamer was an excellent candidate for a photo mosaic. In 2006, Tane and the sanctuary's maritime heritage staff received funding from NOAA's Maritime Heritage Mini Grant Program to create photo mosaics of 6 shipwrecks. All part of the Sanctuary Shipwreck Trail, the centerpiece of its Maritime Heritage Education Program.
We have a couple of the shipwrecks in the Upper Keys, highly visited sites, City of Washington and Benwood. San Pedro is an archaeological preserve. We figured we would get the most benefit out of having these photo mosaics on these shipwrecks in particular. We didn't want to exclude this period, Adelaide Baker, this period, or the North America also, so we chose several of the best representative sites on the shipwreck trail.
The time in the water with the camera is just the beginning of the work involved. The longest process is downloading the images into the computer and then manually going through it, one photo at a time, matching the still images. The San Pedro wreck, for instance, may need over 150 still images to construct the puzzle of the wreck, and the San Pedro wreck is a relatively small wreck, at 40 to 50 feet long.
Like any kind of archaeology, the easiest part and the shortest time is in the water. I would say it's probably a 5-to-1 ratio, or 10, no, it's probably a 10-to-1 ratio. So if I spend an hour in the water, I'm spending 10 hours up on the computer processing the video, getting it as to still images on the computer and piecing it together. Because especially like a wreck like the Benwood's about 600 feet long. That's gigantic.
The new photo mosaics will be a valuable companion for divers who visit Keys Shipwrecks. The sanctuary has produced line drawings of the 9 sites on its shipwreck trail. Local dive shops received hard plastic cards with these images and descriptions of each wreck free of charge. Their divers may borrow these and take them underwater to guide them on their tour of each wreck. And there is a list and descriptions of the ships on the shipwreck trail available on the World Wide Web. But the photo mosaics provide divers with a 3-dimensional image of the entire ship, far beyond what a simple sketch or single photograph can portray. And perhaps more important, for those who can't dive and snorkel these sites, Tane's images will allow them to tour these ships while seated comfortably before their computer. Some sites, such as the Queen of Nassau, lie so deep that only the most advanced divers will ever explore them firsthand. Another use for Casserly's giant photos is the documentation of the current conditions of the shipwrecks. Part of the National Marine Sanctuary Program mandate is to preserve cultural history, and with hurricanes passing through South Florida regularly, there is always a chance that the shipwrecks within the boundaries of the sanctuary could be damaged and destroyed. Now, by creating a photo mosaic of these shipwrecks, there is a snapshot in time, a photo documentation of Keys history. Viewing series of photo mosaics over time will help managers judge whether a shipwreck is deteriorating and whether they need to take steps to preserve the valuable information they contain.
The National Marine Sanctuary Act, part of the Act builds in that we protect not only natural resources but cultural resources. So our site here in the Florida Keys has a tremendous amount of these cultural resources.
There are more than 500 years of shipwrecks dotting the shoreline of the Florida Keys. Each wreck has a story, a place in history, each a unique time capsule. The photos that Casserly is taking will open the door for those interested to delve into these histories, to learn about the past. With a bit of ingenuity, Coupled with a passion for the maritime history of the Florida Keys, the Photo Mosaic Project is one more way that the Florida Keys National Marine Sanctuary is serving the public trust.
We can turn those into products for the future, posters for the dive shops that go to these sites, put them on the website and let people download them if they choose to put them on waterproof paper and possibly take them under with them when they go diving to the site so they can have a good idea of what they're going to see.
The photo mosaics that Casterly is constructing make it easier to get acquainted with the cultural treasures of the Keys. These shipwrecks belong to the people of the United States, with the NOAA staff acting as stewards. But what good is treasure if it can't be shared? In the summer of 1947, a heat wave drew beachgoers from miles around to the small city of Venice on Florida's Gulf Coast. Families with umbrellas and blankets cross over dunes of pristine white sand to find themselves in the midst of a spectacle unseen by local residents. An offshore breeze carries with it an ominous odor that tickles the throat and overwhelms the senses. Carcasses of fish line the tide line of the beach. Residents jump to conclusions. Could it be military activity? Toxic waste? What could cause an impact of this magnitude? Who or what was responsible? The culprit, we now know, was the organism Karenia brevis, which can form toxic blooms known as the red tide. In 1947, little was known about the microscopic algae that can kill fish and other marine life and cause discomfort to humans. Today, red tides are a regular event in Florida's Gulf waters, occasionally reaching to the Florida Keys. The term red tide can be misleading. Harmful algal bloom, a less catchy but more accurate term, can turn waters shades of green and brown.
The thing to remember though is red tides are a natural event. There's records from as far back as the Calusa Indians that indicate there was red tides even back then, before there was the sprawling population we have now in Southwest Florida.
In the winter of 2005, unusual reports of fish kills at the reef in Florida Keys National Marine Sanctuary mobilized scientists with Mote Marine Laboratories' Center for Tropical Research to embark from their Summerlin Key facility to investigate. While the waters to the north of the island chain of the Keys occasionally experience red tide, its presence at the offshore reefs on the Atlantic side of the Florida Keys was unheard of by locals.
We've got a call from a dive shop, Captain's Corner, down in Key West, and they reported a fish kill underwater, which usually when we see a red tide, you'd see the fish dying, or they have been dead and floating on the surface of the water. But this time they saw them dying on the bottom, so this was just happening. And within at least 30 years, nobody has seen a red tide on the reef. So what I did was went down, collected a water sample that the dive center had brought in for us, along with some of the dead fish that they brought in, and brought it back to the lab, looked at it under the microscope and discovered it was from a red tide. It was a low to medium concentration.
For such a tiny organism, Karenia brevis can pose major impacts on sea and shore. In addition to fish kills, an extended red tide off Florida's west coast in 2005 resulted in the death of large numbers of manatees and dolphin. The organism can cause respiratory irritation in sensitive individuals as it becomes airborne from waves breaking on the shore. Karenia also poses a threat to humans by way of contaminated shellfish. In extreme cases, the vast number of red tide organisms and decaying fish and other marine life can deplete oxygen in the water column, resulting in the death of organisms that live on the bottom, such as coral and sponges.
There are other species in different parts of the world that also release toxins and cause harmful algal blooms. The dominant form for West Florida is Karenia brevis, brevitoxin that is released by the harmful algal species This can affect species both directly and indirectly in the water column. Fishes can concentrate the brevetoxin through the prey that they feed on that have absorbed the brevetoxin. It's one of those moving up the food chain effects where toxins can be concentrated, going up from the prey items to the predators, to the top predators.
While the state of Florida monitors the occurrence of red tide throughout the Gulf Coast of Florida, Mote Marine Laboratory technicians Eric and Corey conduct regular red tide sampling in the waters of the Florida Keys, as well as conducting real-time data on water composition.
Mote Marine Laboratory has been involved with the state of Florida for a number of years with their statewide red tide monitoring program, not only with monitoring, but also with toxicology studies and even now microbiology studies, learning more about the red tide organism. Here in the Florida Keys, we've had a field station for about 5 years, and we've been monitoring the Gulf side of the lower Keys for pretty much since the lab was started in 2000. And then once you get past the sandbows on the reef line, the water's still real murky, but there's no red tide. So I have a feeling there's pockets of it, and that's kind of what we saw last time. And the satellite image shows these little spires coming off, actually existing offshore as well, these little red tide pockets. So any samples you can get would be really
Mote's network of volunteer observers also played an important role in determining the extent and duration of the red tide, helping researchers to decide where additional sampling may be necessary. Volunteers can contribute observations or even take water samples that are collected by Mote staff and sent for analysis.
And another element where Mote comes in to help out with observations is what's called MIRA, which stands for Marine Ecosystem Event Response and Assessment. And this is where Mote utilizes what we might call eyes on the water, where any observer, a scientist, a volunteer, a fisherman, a dive operator can contact Mote with any unusual observation they see. Discolored water, a dead turtle, a fish kill, anything. And Mote serves as a central clearinghouse for this information, which they then post at a website so that anybody can take a look at unusual events that are being observed in waters around the Keys. So this combination of the harmful algal bloom sampling and MIRA make Mote a very important partner for the Florida Keys National Marine Sanctuary.
A lot of people that have been on the water for years have a better understanding of what's going on in the marine environment than many scientists do. And we want to utilize that information, and we've been working with the Florida Keys National Marine Sanctuary, developing a program over the last 5 years to encourage people to report their observations so that we can learn more about the changes that are going on in the marine environment. And by getting these anecdotal reports that otherwise might have sort of been lost in the shuffle between different agencies when they report, we try and act as a clearinghouse to pull all that information together. And taking multiple reports, we can start to draw a bigger picture about when large-scale marine events may be occurring in these waters.
The Florida Keys are not affected by harmful algal blooms as frequently as communities on Florida's west coast, but long-lasting blooms occasionally travel down the coast on currents. Complementing water sampling and volunteer observations, scientists can now turn to satellite imagery to help them track the movement of algal blooms.
It works, but it requires this combination of the large-scale observations that we get from satellite imagery, where we can track over time the movement of elevated chlorophyll, and then once we know the composition from the water samples, we can actually see whether a harmful algal bloom is slowly moving from the Naples area down to the Keys. And that can take a couple of months. That's how slow the water flows are along the West Florida shelf. Water circulation in the Florida Keys region is very complicated and driven by two main forces. One force is what's called the loop current, which enters into the Gulf of Mexico through the Yucatan Straits, turns around upon itself, exits through the Florida Straits, gets renamed as the Florida Current, and then eventually becomes the Gulf Stream, which is one of the most powerful current systems on the planet. The second force is a slow migration of water along the West Florida shelf from the north to the south. The rates of movement are slow, but that's one of the most important mechanisms that transports nutrients, algal blooms from the northern part of the West Florida shelf down into the Florida Keys.
While researchers are investigating ways to stop red tides once they have formed, completely eliminating these blooms may not be possible or even advisable. Algae are primary producers, organisms that convert sunlight into chemical energy, forming the base of the web of life. We don't fully understand the role these blooms play in the ecology of our oceans. However, while scientists may not be able to make a red tide disappear, they can use the research collected to help predict where a red tide will travel and reduce public health effects by warning residents to steer clear of the beach. The ability to see where and when a red tide originates may lead to answers about why they occur.
Managers and scientists can use this type of information that we get from the satellite imagery and the water samples to improve our scientific understanding of what's driving phenomena such as harmful algal blooms and whether there are any management steps that we can take to try to ameliorate them. What we tend to find is that for something like a harmful algal bloom that's a natural phenomenon for the most part, there's probably very little that we can do other than alert the public and develop a long-term understanding of the seasonal cycle of what causes harmful algal blooms to form and then eventually to go away.
Historical accounts confirm that red tides have occurred in Florida for hundreds of years. The big question is whether human activities may be causing these blooms to be more frequent and more severe. With Florida's economy dependent on tourists who come to enjoy the state's beaches, boating, diving, and fishing, much is riding on the answer. Some suspect that increasing amounts of nutrients such as nitrogen from coastal development may fuel red tides. As scientists work at proving or disproving this hypothesis, improving the quality of water that eventually runs into our oceans is a necessary precaution.
It's a likely enough possibility, and it's actually really a no-brainer that we should minimize our nutrient inputs into coastal waters so that we don't even have to worry so much about whether we are driving worse harmful algal blooms, the attendant fish kills and manatee die-offs and turtle effects, the effects on public health, all of those consequences. It's just commonsensical that we should minimize the modifications that we're making to coastal waters in terms of water quality.
In the study of red tide, scientists are taking full advantage of both high-tech observing systems and low-tech field observations. Using tools, both old and new, they are working to better predict red tides, understand what causes and sustains them, whether human activities are causing red tides to worsen, or whether these blooms are a force of nature beyond our influence. The information researchers provide will help Floridians and their visitors live in harmony with their natural surroundings.